In this video, we're going to be covering the uniform distribution, which is a distribution where all values are equally likely. I want to start with an example, and from there we will draw the picture related to uniform distribution to help us see what's going on, and then answer a couple of questions about it. And that'll be pretty much it for this video. So let's suppose the actual commuting time for a train is uniformly distributed between 64 and 74 minutes. Well, let's actually draw the picture for what that means. So I'm going to write along the x-axis the amount of minutes that this takes. 65, 66, 67, 68, 69, 75. All right, and I'll write this in here, label these points along the axis. And we have a uniform distribution. Any kind of distribution must have a total area under the curve of 1. We have a uniform distribution, so it's also a rectangular shape because everything is equally likely along this interval. Our endpoints are 64 and 74, which gives us a length of 10. So our height must be 0.1. if we are going to have an area of 1 under this curve. So the total area here is 1, right? 10 times 0.1. So, and I'll even write that down. The total area under the curve must be 1. And that's true for any probability distribution. But specifically for a uniform distribution, the height of this curve is the same everywhere. All right, so how do we figure out the next question? So let's ask a couple questions related to this. What is the probability the commuting time will be, and then part A is going to say less than 70 minutes. Okay. Well, if we look at this graph that we drew up at the top, we want to know the area under the curve between 64 and 70, right? This is the region that is time less than 70 minutes. So we can find the area of that. Well, how do we do that? This is 70 minus 64, because that's our length, divided by 10 or multiplied by 0.1, right? Those are the same thing. Sorry, I will move the picture again. So 70 minus 64 over 10, or in other words, 6 over 10, or 0.6, or 60%. So the probability of a 60% chance that your commuting time will be under 70 minutes if you take this train. Okay, well, let's quickly answer two more related to that. What about what is the probability if the commuting time is supposed to be between 65 and 70 minutes? Well, it's the same thing. The length here is 70 minus 65, or 5. We multiply by the height, which is 0.1, so it's the same as division by 10. So 5 over 10 is 0.5. And finally, what if we asked what is the probability that the commuting time will be greater than 65 minutes? Well, our maximum is 74. So we get 74 minus 65 all over 10, which is 9/10 or 0.9. This makes the calculating probabilities on a uniform distribution really simple because it's just the area of a rectangle. So we multiply by the height, which is just the 1 divided by the total length. That'll be the height of your rectangle. And then multiply that by the width of your rectangle for the given information you're trying to solve. And that's how you find the probability on a uniform distribution, which is pretty simple compared to everything else we've done in this class. So it's kind of nice. Real quickly, I'm just going to write down the formulas for the mean and standard deviation. So the mean of the uniform distribution is, and this is mu is equal to b plus a all over 2, which is just the average of those two values, of the higher and lower values. So that's pretty nice and simple. Then the variance and standard deviation. This one is less intuitive. I'm not going to talk about why it is this way. But the variance and standard deviation of the uniform distribution is, all right, so the variance is sigma squared, which is b minus a squared divided by 12. And of course, the standard deviation is the square root of that. So sigma, which is the square root of b minus a squared all over 12. And that's it. So if you have a question that asks you for the mean and standard deviation or the variance of a uniform distribution, just plug it into one of those three formulas, the appropriate one of those three formulas. And that is it. And of course, what are B and A? Those are just to make sure this is all true, where B is the maximum value and A is the minimum value. And that's it for this video.